Hey guys, this is Mr. Harper. I wanted to go over a couple problems and then have you work out 3 problems yourself. And this would be the work for Wednesday. I'm recording it on Tuesday, but this will be something you need to do on Wednesday. So on Tuesday, I asked you to graph some exponential functions and put a video that was on YouTube, but I'm going to do the video myself today. The first thing I want to say when you're graphing exponentials, again, the reason it's called an exponential is because the x is in the exponent. So that's what makes it an exponential. And this one's an exponential growth, and I know that because the number being raised to the power is bigger than 1. And so I didn't mention that necessarily yesterday. I'm not sure if the video mentioned it, but that's how you know it's an exponential growth, is if this number here, not the 2, but the number that's being raised to the power, if it's bigger than 1, then you know it's a growth rather than a decay. So this is an exponential growth. I'm not worried about the domain and range. For the sake of convenience, we're just not going to worry about that. I just want to make sure you know how to graph. So the first thing I want to say is your horizontal asymptote is going to be this number out here. If there is no number out there, then it's at 0. So what I'm going to do first before I do anything else is graph the horizontal asymptote. So I'm going to go to -1 on the y-axis, again the y-axis, and just draw a nice little asymptote like we've done in the past. That's the first thing that you need to make sure you do. So sometimes the graph will be above that line, sometimes it'll be below. And there's a way to see that. If this number right here, the 2, if it was negative, it'd be below. If it's positive, it's going to be above. But once you get the points here, you'll be able to see where the graph is anyway. So first thing is horizontal asymptote, which we did. The second thing is we're going to plug in some points. Now I've given you points here, and the reason I've given you these points is because they work out conveniently. What you'll have to do if I don't give you the x values is just try points out and see what they get you. And eventually you'll begin to see nice points like 1 and 5, but you do need at least a couple fractions because of the nature of these graphs. So you'll notice I already have the y values in there. The way you get those y values is you just plug in the x values. I'm not going to plug in or show you how I did all of these, but what I'm actually going to do is show you how you plug in -2. So I'm going to take this problem, so 2 times, and again forgive me for my writing, 3 to the power of, so notice it's x plus 2, so I'm going to put in the -2 for x, so -2 plus 2, and then -1. So what is -2 plus 2? Well, that's 0. What is 3 to the 0 power? Well, that's 1. So this is really 2 times 1. And again, I got 1 from 3 to the 0 power. So then 2 times 1 is 2, and 2 minus 1 is 1. That's where the 1 came from. So you're just plugging it in. Now for some of you who have calculators, like the ones we have at school, you can just plug this into the table function, and that'll work just as fine. In fact, it works better. Okay, so to me that's a lot easier, but if you don't have one, you're going to have to just plug them in and get the points, which I know is inconvenient, but it's just the way it is. So now you're just going to graph these points. So -4, -7/9, which that's actually the same thing as like -0.7 repeating. So if I go here and I go to -4, I'm going to go to -0.7, which is about here, and I'm going to change colors here. I'll use red. So -4, -0.7 will be about right there. -3, -1/3 would be about, let's say, right there. -2, 1 would be there. And -1/5 would be here. And notice how the graph is going. Let me say this. It will not go past the asymptote, so it's going to be really close to the asymptote. It's going to go through these points, and then it's going to go up really fast. That's generally how exponential graphs do. Is they kind of have a really flat area, and then all of a sudden they shoot up real fast. And so that would be the graph of that. So again, the first thing you need to do is worry about the asymptote, and then you're going to plug in the points. So I'm going to go to the second one real quick. I've already got the points, and again, you're just going to have to plug those in. But the first thing I want to do is the horizontal asymptote, so 2. So I'm going to go to 2 on the y-axis and draw my nice horizontal asymptote. Now, this graph is actually going to be below this line rather than above it. And the reason I know that is because the number in front is negative. That number tells me if it's going to be below or above. And even if you forget that, once you start plugging the points in, it'll become obvious where it's located. Okay, but also what's different about this one is the fact that what I'm raising to the power, so what I'm raising to the power here is a fraction, so it's 1/2. So this actually makes it an exponential decay. Now it won't necessarily look like that because it's below the line here, but just know that if the number being raised to a power is less than 1, then it's going to be an exponential decay. All right, so again, to get these -6, -2, 0, 1, 1.5, all that, you have to plug these values in, or you can just use the table function on your calculator. Okay, this is a long video, but I'm gonna go ahead and graph these real quick. So -1, -6 would be here. 0, -2 would be here. 1, 0 would be here. 2, 1 would be here. And 3, 1.5. So what you'll see is, again, graphing, or actually getting the points, it makes it easy to know where the graph is. I don't have to figure out if it's going to be above or below. I can just plug in the points and see where they come out. Okay, so and that would be the graph of that, and it gets really close here and keeps going. So hopefully this helps. I know it's kind of seemed to rush through it. Again, I'm not worried about the domain and range. Don't worry about that. The main thing is horizontal asymptote, and then plugging the points in to see what you get. And if you're plugging in points and you're getting nothing but decimals, that means you just need to go in the other direction. Because eventually, if I kept going to like 4, 5, I would just keep getting decimals. I'm not sure, it'd be getting really close to 2, something like that. I'm not sure the exact numbers, but they'll just keep getting really close to 2. And the reason that is because they're getting really close to that asymptote. So if you are just getting numbers like that, you need to go in the other direction. Anyway, hope this helps. Please let me know if you have any other questions.